Okay, so my name is Seth Russell, and today I'm going to be talking about natural language processing. So I'm with the University of Colorado Anschutz Medical Campus. Started with data science to patient value, which is now kind of morphed into the CORDS data science program. But I've been a software engineer for many years, worked at Intermountain Healthcare for I don't know, about a decade or so, and then been here with the university for about 4 years now. But been doing a lot of data science work here at the university. The last year, like everyone else, has been mostly COVID research, but done lots of other things, ranging from synthetic data to I don't know, software testing, testing for research software. To natural language processing and so on. But just want to point one thing out that's not maybe standard for this is that I do have all these materials and some code examples on my GitHub page, which I have linked down there at the bottom. So if you download the slides from the website, you can go to that link or just copy it. But it should be on pretty much all the slides. I think there was one or two that it didn't fit just because of the images. But yeah, so today, kind of the learning objectives that I have, hopefully it aligns with what you're looking for, is one, just get a general idea of what natural language processing is, to a knowledge of the ethical implications of data reuse in natural language processing, a knowledge of where to get some text for NLP, and then how to use and learn more about some basic NLP techniques. So I guess maybe just another thing that I want you to learn is that NLP is not simple or easy. You're not going to be an NLP expert at the end of this, but hopefully you've learned something interesting, and then you want to pursue it further. And then maybe you'll be on a team that they're doing NLP work, and then you can help in that, or kind of learn more and then become an active participant in that process. So I wanted to start actually with Watson. So I don't know if any here has seen Jeopardy, but about 10 years ago, the big thing with NLP was IBM's Watson system. And so it was, it was 2011. This is from an article back. So about exactly 10 years ago. But this automated question answering, or question asking system won Jeopardy, and it beat Ken Jennings, who had been at that point, the world champion of Jeopardy. But the system Watson was named for IBM's founder, first CEO, Thomas Watson. But so in my talk, I'll throw in a few quotes from a different Watson and Sherlock, but it's kind of related. So more recently, this was a kind of an image screenshot from 2020. This group called OpenAI, they came up with a language modeling software that could almost write, or could kind of write natural language like syntax. And so you could feed it a prompt, and then it would spew out something that's mostly related. And if you carefully picked the examples, it would almost look like something a human would write. Often there'd be data inconsistencies or artifacts that weren't real, but in a lot of cases it looked just like something a human would write. But then more recently, especially in the healthcare field, IBM has tried to take that artificial intelligence software, did a lot with natural language processing, and then try to use it to help healthcare systems solve problems. So I know they did some work in the cancer area, and it didn't work out, I think, as well as they had hoped. And actually, just a couple months ago, IBM is shopping around trying to find somebody maybe that could buy this system, because getting the millions or even billions of dollars back that they put in, it hasn't materialized. And the one actually from the previous slide, the OpenAI GPT-3, they spent I don't know, $5 million, I think some estimates say, just on hardware to train these models. But then if you think about, all the dozens or even hundreds of researchers, software developers, QA people, everything, it's a lot of money that people put into these NLP systems. And so far, it's hard to get that much money back, but it's still an exciting time for natural language processing. So I think, a lot of people probably see these articles in the, either popular media or even, research journals. Google, publishes things quite frequently, Microsoft, OpenAI, a bunch of other groups. And so, people are like, just let's go, let's do it. So, just like I think some of these adventures that Watson and Holmes had, it doesn't always turn out maybe the way you hope, but hopefully after you see this, you can, see some of the real advantages and, see how you can become involved and use it in your research. So kind of a high level overview of main areas of natural language processing. There's document retrieval, information extraction, knowledge representation, word concept disambiguation, automated reasoning, classification, sentiment analysis. So I'll just show you a few examples of some of these, and and we'll dive into a little more details. But so document retrieval is a very common thing that people use today and have been for ever since the internet came around. Back Ask Jeeves and some of the even earlier ones. Yahoo's been around for a long time. Google was a little newer, but nowadays everyone looks for documents on the internet by going to a web search engine. But so since the initial days, they've actually advanced some to do more information extraction. And so instead of, if you're, say, for example, searching for, what's the hours the Smithsonian Museum is open, it doesn't just pull up a document that has the hours, but it actually extracts the part that you probably care about, and it puts it on the page there. So, someone's asking for the hours, they probably want the address and then the hours that it's open today. And so it does that. And another area here. So this is, when was this? April 6th. So just, a couple months back. This was a really big thing with, the kind of storming of the United States Capitol and other protests that have been going on online over the last year. And that software or these websites that allow users to provide content, they want some way to moderate that content. But one of the problems, for example, with YouTube is they get, I can't remember, I think it's in this article, you can look at it later, but millions of videos uploaded per day. Facebook, there's millions or even billions of posts every day. Same with Twitter, and it's not possible for a human to review all that, although they try. But what they want to do is train some software system to do that. So they have humans that will rate this video as appropriate for all ages or not, or disinformation or whatever, and then they use that to train some algorithm that then kind of carries on that actions that the humans would have done. And one of the reasons for that not only is the sheer volume, but I've read other articles that actually say people that are the YouTube content moderators had to quit because of post-traumatic stress syndrome. That the content they have to view sometimes is so disturbing that they just can't do that job anymore. So it'd be nice to automate that so a human doesn't have to put themselves through that. Let's close that. It looks like, I don't know if it's showing on your screen with the little pop-up about the recording in the way. But so there's a lot of different techniques that can be used for NLP. And over the time that NLP has been used, the techniques that are in vogue have changed over time. So you kind of think of it like an attic in a house. There's room in the attic for a lot of different things, but there's not room for everything. So you got to pick and choose what you want to put in there to decide to keep And at some point, it will get too full, and you got to throw something out. So just think about what you want to put up in your attic, and keep track of that. But historically, a lot of the NLP systems were rule-based. So typically, it was based on rules of grammar that everyone learns in like high school. But trying to write those down, most people, even though they have native fluency of the English language, cannot write down all the rules of grammar that they follow instinctively. And so a lot of times there was an NLP linguist, a specialist in languages, that would create these natural language processing systems. But further on, there's been other methods that have been developed. But some of those early systems are still in use and still provide great value. But yeah, so here's some of the common techniques. I think even before some of the more semantic analysis was regular expressions. And so that's just basically a pattern matching language that you can identify words, spaces, numbers, special characters, so on. And actually, well, let me just show you a quick example here. So a natural language processing system that I'm working on with a pathologist. I use some regular expressions here to basically find parts of the document that we care about. And so regular expressions, it's basically, this kind of gobbledygook here that doesn't really, if you don't know the regular expression syntax, then it wouldn't make sense. But a /W, for example, is a word character. A /S is a space character. A /D is a digit. But there's tools out there. For example, this one here, it's a regular expressions 101. So in this example here, I pasted one of the longer regular expressions and had it match some de-identified text. And so you can see here that there's groupings in the regular expression that are highlighted in different colors. And so, in this example, we're trying to extract, the various things reported on in a pathology report. And so we have what procedure was done. Well, it's a radical cystostectomy. What's the size of the tumor? Where is it at? And those kind of things. So now let me go back to the list here again. Oops, too far. So another thing that's done is kind of stemming and lemmatization. So in the English language, and other languages often have a similar form. You'll have letters on the end, like the ED, ES, S, so on, that does the kind of, subject-object agreement, those kind of things, or plural versus singular. A lot of times in NLP systems, they'll actually throw out, like, the verb to walk could be, I walk, I walked, I'm walking, and all those different forms of the word walk. You want to narrow them down to just the word walk. So you kind of throw out all the extra letters. And they're not really extra, but it helps from a natural language processing perspective to simplify things. Another thing in the English language, if you count how many times different words appear, the most common word that is in the English language is the word the. But if you read a sentence, a lot of times you could take out the word the and you would still understand what's going on. So some NLP techniques are based around just throwing away words that have high frequency but low meaning to frequency ratios. And then kind of the last two are newer techniques. A lot of machine learning techniques require numbers as input. And so people have come up with techniques for mapping words to numbers. And then you can, even have more complicated than just, say the word the is the number one. But actually you can have vectors that can help keep track of senses of meaning. So maybe you have 10 positions, 10 numbers that work together to identify, amount of maleness versus femaleness, or amount of, a location versus, a body part or something like that. So they have ways of representing words as vectors that then you can feed into machine learning techniques. And then, the most recent stuff is more in the deep learning and language modeling, and I'll talk a little bit more about that. But it really, everything here builds on previous work that, it's not all in isolation. So yeah, the semantic analysis, I'm going to show this little diagram here. So, take the simple sentence, John hit the ball. Well, you can break that up. It's a sentence, but it has kind of a noun phrase and a verb phrase. In this case, it's a really simple sentence. The noun part is just John, and then the verb part is he hit the ball. But by identifying which part of a sentence is which, then you can, okay, we want to say, for example, we want to find entities in a sentence. So you would want to find basically nouns in a sentence, and that would help you to identify entities in a sentence that then you might, process later or do something with. But all of this is really built around the idea of that, English is structured and organized. And based on this, people can build kind of language models. And a language model really is just the probability of a word occurring in a certain order in a sentence. So for example, John hit the ball, where, like it's probably that sentence, at least in English, it's going to start with a noun. You wouldn't say hit John the ball. I mean, it would make, you could understand it, but that's not the way somebody, a native English language speaker would say it. But so a language model understands that John is most likely the kind of the start of the sentence, whereas, it wouldn't be ball hit the John, that wouldn't make sense. So a probability distribution of ball hit the John would be very low, unless, somebody's last name happened to be Ball. But anyway. Let me go to the next thing. So these language models have become, whoops, sorry, twice there. Okay, there we go. These language models have become more complicated over time. So initial language models, just had, 100 million parameters, which is a lot actually, but they've been growing, kind of exponentially over the last few years. They really started maybe in, before 2018, not too much before that, but each year somebody's like, I got one that's 10 times bigger. I got one that's 10 times bigger. And, just like an early exponential curve kind of starts out slow, the OpenAI GPT-3 that I mentioned earlier is, kind of the tall end of the hockey stick here. And it really is just so much bigger than all previous language models, but that's why I can do this more, native language generation. It's pretty, it's very impressive. But they're using those same techniques to not only generate language, but I've seen it to generate, software code. They can generate, poetry. They can, even apply that to generate, just a lot of things that you wouldn't think would be language-based, but like, user interfaces and things like that. It's pretty impressive what they can do with it. But so just to kind of give a little better idea of how these language models work, typically they're self-supervised. They take human language as input, and then basically the software just takes that simple sentence that we saw earlier, and kind of reading from left to right. First top to bottom. They take one word in the sentence and mask it out, and then have the language model learn which words should go in that position. So take out the first word, then take out the second word, and then take out the third one, and so on. And they'll do that with gigabytes of text. It's hundreds of millions of web pages they've downloaded from Wikipedia, Reddit, PubMed, anything they could find that's freely available. But so like I mentioned earlier, the most common word in the English language is the. So, an initial first simple guess would be just put the word the in. And, the language model gets trained, well, that doesn't work. Maybe you is another common word, so try that next. And then it just does that so on until, hopefully it gets to the point where, it's a really high probability, John hit it's a ball maybe, or hit the house, or he hit the, bat, or, something like that. But it just gets trained over time to recognize which words go in which order. And typically, actually, they do this in a forward fashion. So you think about, well, what word comes next, but then they also do in a backwards fashion where I have this word at the end, which word would go before it? And so they learn the context of the sentence and the probability of words in those sentences. But so these language models here, they're trained on just general English text, but then Wikipedia or books or whatever. But then they take that language model to then do something more specific with it. So in this case, I'm showing here on the right is a classifier. So the common thing that people have been working on for quite a while is is this email spam or not? So with the wonder of the internet, the most important question is is this a real email or not? But so they take something that understands the human language, which words usually occur in which order, and the probability of a word going in that position, and then they say, well, this one is spam, this one's not spam. So it takes the training on the left and then some additional training on the right to go for a specific task. So in this case, you got buy these pills. Well, that's probably spam. Win cash prizes. It helps usually if it's misspelled, because for some reason a lot of spam usually is. But then if it's like a specific name that's not a common name, then you might think it's not spam, because the probability of the tradies appearing just in random English text is quite low. So these same technique can be applied to the medical domain. So for example, somebody writes in a pathology report, number of lymph nodes involved / examined. Well, in the kind of lexicon of College of American Pathology, they have a separate concept for number of lymph nodes involved from a concept of number of lymph nodes examined. But from an English language perspective, if you look at kind of the probability of those words occurring together, it's very close to these two concepts here. Whereas this other one, no lymph nodes submitted or found, similar sentence construction, but is a lower probability to occur. So these natural language processing systems, they might use regular expressions, stemming, lemmatization, deep learning language model, but that's really only a small part of a natural language processing pipeline. This is just an example from a research paper. I forgot to put the year, just a couple of years back, but basically, if you're doing natural language extraction from a clinical note, it's not just you don't just do regular expression matching on the note. You have to get each health record and then find how many notes are in the health record, and then deal with how does the text come across. Sometimes it's a PDF, sometimes it's just plain text, sometimes it's rich text format or some other format that then you have to either convert or extract the text out of. And then there's in the English language, like this one's talking about certainty versus experiencer. So if you're reading a clinical note and the patient is telling you their family history, you need to separate family history from the patient's history, and that's quite a complicated task. But there's dates on there, different. You might have like a change in electronic medical record system over the period of your study, and that would completely mean you'd have to have multiple pipelines to extract text, or potentially. So here's just kind of another one that shows the process, and the natural language processing part is really only a small part of a natural language processing pipeline. A lot of the data curation, data extraction, quality assurance, validation is all built around that is very complicated and not to be over trivialized. But so, once you kind of learned about, natural language processing, You want to think about, how I can use this, but you want to be careful. Don't speculate too much, and get yourself into trouble. So this is where I want to talk a little bit about the ethics of reuse. So in the electronic medical record, it's kept. One reason you could say it's kept is for financial reasons. So the healthcare system gets paid. Another reason you could say the electronic medical record is kept is so they won't get sued or can protect themselves against a lawsuit. Another reason that it's kept is potentially that they're trying to help the patient over a period of time, or that the doctor needs to be reminded about, or nurse, what did we do with this patient last time they were here? Why are they here this time? So it's kind of a human communication medium, but none of those reasons are probably the same reason that you're doing some research involving natural language processing. So you think about we're, as a computing professional, most research today involves some kind of computing, and so you got to think about what you're doing with the data, what your impact is, and hopefully you're doing something for the public good. And one of the things that I've heard recently is if you think about, well, what's the worst thing that could happen with this this system? So like, for example, the Apple Face ID thing, it tends to recognize white males better than non-whites, or like family members can unlock each other's phones, which may or may not be a good thing, but just the training set that went into that maybe wasn't as diverse as the population of people actually using the phone. So that comes out that, well, I'm from India and it doesn't work for me, but it works for my coworker who's Caucasian or whatever. Why is that? Well, they needed to do a better job training their system. But the same thing goes for NLP, that if you're training your system on clinical notes from a particular one specific clinic, and then you try to deploy it even at the same healthcare system at a different clinic, doctors have different habits that they follow when they create their notes, even though they might all use the same electronic medical record system. You'll get different results in the end. But so these are kind of some of the ethical principles that the Association for Computing Machinery has espoused, and there's a lot more detail here, but just some of them: avoid harm, be fair, take action not to discriminate, respect privacy. Hopefully all of us go through kind of the city training for biomedical researchers or social science research, that we learn how to protect the data. But then got to think about what harm could even happen to the people that provided this data, because I'm using their data for some other purpose than what it was collected for. The IRB does help with that, but they don't actually look at every line of code that you write or every person's record that you get. And so you as the researcher has to have a little more a thought process involved. But I guess the last thing, if you want to do natural language processing, you need data. So Sherlock Holmes is always saying he needs more data. He can't make a conclusion without data. So that's same with researchers. So at the University of Colorado Anschutz Medical Campus, we have a health data compass that collects data from Children's Hospital and University of Colorado Health System, and other sources. But with IRB approval, you can get access to a lot of clinical notes to do your research. If you don't have, if you're not with the University of Colorado, or it's difficult to get that IRB approval, there's actually the Beth Israel Deaconess. They have the MIMIC data set that has clinical notes along with a lot of other observations on patients. And for that, you basically just have to do city training. The data's been de-identified, but you can get access to that. But there's other non-medical data sets, Kaggle, Hugging Face, Amazon product reviews. I've been to conferences where medical researchers just use Twitter, because Twitter, anything that somebody tweets, or well, for the most part, is publicly available. So it's public information. People are always tweeting about, oh, I broke my leg, or my dad has to go to the emergency room, or, I'm suffering from depression, what can I do to help myself? People post stuff like that on Facebook and Twitter all the time. And so that's, medical information that you can use for some specific research. But you really need to have the data before you can start doing work. And so once you come up with some idea that you have, some research idea, but then you got to actually put it to work by getting medical information, and then starting to work on that. There's a lot more tutorials out there and resources that could be helpful. I won't review these, but there's several people here at the University of Colorado that have created free, publicly available natural language training courses, so you can do that. Take a look at that on your own, or there's various books and texts. So University of Colorado Boulder, one of the, actually I can't remember if he's still there or not, but he and this other guy, they wrote one of the most popular textbooks on natural language processing. But that's the speech and language processing, but there's other free courses. And then there's a lot of different libraries. This is just a couple of them, but there's more out there. And then these are some of the researchers here that I'm familiar with that do natural language processing. I'm sure there's others. And then let me just real quick here, I'll give time for questions. I want to just show one other thing. So from my GitHub page that's linked at the bottom, I have a notebook, a code notebook that you can view and run through. And it's basically a text classification system. There's a website that has clinical notes. And this system goes through how to predict the medical specialty. So it's basically a classification task. And if you just click the link here at the top, it'll actually open up in Google Colab, which is you can run a GPU-based system for free. And so as long as it's public data, not protected health information, you can actually use that to compute and run a natural language processing system. So I don't really have time to walk through line by line, but you can take a look at this on your own time and then see how to evaluate how well his system is doing, and to think about maybe this would work for research that you're interested in. But yeah, I guess any questions at this time? If not, I mean, I can go into that in more detail, but I don't know if Mike.
There's no question at the moment in the chat. However, if participants want to put something in the chat, or you can also feel free to go ahead and unmute yourselves to ask a question verbally of Dr. Russell, that would be great. There's no questions coming in. Seth, if you'd like to go further into what you were just showing.
The example, sure. Yeah, so I can. There's also, I know there's the chat available on the website, so we can use that too. If you come up with a question later on, you can reach out to that or reach out to me by email. But so in this natural language processing example, I use it's a library called FastAI. So it's a deep learning language model based approach. But it does work much better on a specialized computer. You could do it on your laptop, for example, but to run through this example would probably take 1 to 2 days just for your laptop to run it. If you can do it in Google Cloud or some other advanced computing environment, then it's a matter of like an hour or 45 minutes to run the whole thing. But so I won't go into a lot of details about this, but if you have a Google account, you can do this for free. It even will save data to your Google Drive. So if you're using only the free account, you might run out of space. But there's a couple, I can't remember, what was it, 10,000 notes or something like that. But as you see here, somebody had an allergy visit, or some kind of bariatric bypass, cardiology visit, something like that. So, the doctor created these notes, and then we have these available to do natural language processing on. One of the things I talked about, that you convert the words to a vector. Well, in this case, it adds some special words to or tokens to help you identify uppercase versus lowercase. There's some words that are so rare that they don't fit into the kind of the vocabulary size, so they're not here. So then you build a language model. Most of the language models are trained on general English language, so like Wikipedia, which may or may not relate exactly to how those same words are used in a medical context. So you need to kind of fine tune the language model for your use case. And then once you've done that, you start to build a classifier. But just like any other kind of statistical algorithm, you need to make sure you have enough data to represent the different classes. And so in this case, I took only kind of the top most common medical specialties. But it depends on the data, that you have available for your use case. What you would cut or exclude or whatever. And so I just picked these ones here, and then trained a model to recognize which ones are which. And it ends up being I think it was like 60 to 65% accurate, depending on when you run it. There's this random chance. But if you think about medical notes, history and physical note can cover any kind of medical area, and so that one medical specialty type tends to catch a lot of the others. Or neurology, radiology. There's probably a bunch of radiology things that were done on the brain, so they look like each other. But anyway, I just little discussion items here at the bottom. I think we're out of time now, aren't we, Mike? Or we have? Oh, you're on mute.
Sorry, I'm the one who normally tells people they're muted. Yeah, we are out of time. Okay. But I was going to let you finish your train of thought, or if you had any closing words.
Yeah, no, just thanks for your time. If you have questions, reach out. Take a look at this, and we'll make sure that my presentation as shown is the one that's on the website. I think I made a few minor tweaks there since I submitted it, but I'll work on that here after I'm done. And then if you have questions, reach out.
Sounds good. Thank you very much, Seth, for taking the time, and thank you everybody for joining us. I would like to remind everybody, don't forget, come back tomorrow for day 3. Unlike last year, we've got 3 days this year, not 2. So it's not over yet, and we'll be back tomorrow starting at 10 a.m. Mountain Time. So thanks again, everybody. This is a wrap for day 2. And so we'll be ending all the sessions, and we look forward to seeing you all again tomorrow. And once again, thank you very much, Seth Russell.
You're welcome.